So we move on. So that's this topic. Now I'm taking up the next discussion, which is a discussion on what we call as channel pattern. Okay. So channel pattern, we are back at our discussion here. So channel type we have done, bedrock channels and alluvial channels. Okay, and what are the temporal changes that a river goes through? Now, the conditions in which the channel shifting happens. Okay, and now we are moving on towards one more concept called as the channels according to the type of sediment load. See, there are different ways of classifying a river. Okay, you can classify a river on the basis of type of the lithological features the river is moving on, or you can classify on the basis of type of sediments. So the river can be suspended load channel, suspended, very fine. It can be bed load channel, where the sediments are on the floor. If something has suspended load along with bed load, we call that as mixed load channel. Mixed load channel, okay, will have both suspended and also bed load. Then we can have suspended load along with high sinuosity. We can have suspended load with straight course, okay, and we can have suspended load with sinuosity, okay, and we can also have meander braiding transition channel. So this is a channel which is in stage of transition, okay, from the meander, okay, towards the sharper bends that a river will go through. So this type of meander will have all type of those shifting in thalwick. So this is the type of channel. Now you can look at this page number 406. Page 406. So all of these are essentially types of the alluvial channels. Okay. Alluvial channels, you can read up page 406, the first column. Okay, suspended load, bed load channel, mixed load straight channel, suspended load channel with sinuosity, meander, and so on. Then we have the next section where we are discussing channel patterns. Now, channel pattern is again associated with alluvial channels alone. As you can see alluvial channels here. Alluvial channels which have sediments, which have depositions. These are the ones that can again be reclassified on the basis of some other parameters. And rather than knowing everything here, I would like you to know this one concept, the concept of sinuosity. This can be a question. Okay, discuss what is sinuosity index of a channel. Okay, and what are the types of channel pattern according to sinuosity index. Okay, this is a question for you then. What is sinuosity index? Okay, and discuss the types of channel patterns according to sinuosity index. Okay, so rest not as important. Now, I would like you to see one of the diagrams. Okay. Okay. All of you, this diagram I've taken from page number 399, I believe. Sorry, 396. Okay, of your 7th reading. Now, please look at this page here. This is, I think all of you are with me, page number 396. We have a diagram of a meandering river. You can see this course where river is gradually meandering with those sharp bends. Okay. And if I draw a median line through this, okay, median line that depicts probably the deepest point, this length of this median line is what is called as the channel length. Okay, so this meandering river, the length of this meandering river is called as channel length. Whereas, if I assume the end of the bends as the edges of another river, say think of this river, think of the river, another river, say I remove the meandering one from between, then what I have is a a river may be flowing along this course, the entire width. Okay, we call this as the valley wall, this as the valley wall, and the length of this is called as the channel length. So, it is called as the valley length. So we have two terms here. One is the concept of channel length, and another is the concept of valley length. Channel length is the actual length of the river, while we see the river as a meandering river. Valley length is not the actual length. Valley length is, if I assume this meandering to be removed, and if I consider, okay, the edges of the bends, this as the valley wall, if I draw, okay, a median line between the two valley walls, can you all see this? It's called as, okay, the meandering belt axis. The length of the meandering belt axis is called as the valley length, whereas the length of the actual river is called as the channel length. Now, our concept tells us, okay, that when we are talking about sinuosity, okay, sinuosity is about the relationship between the valley length and the channel length. So we have an equation here. Here it is. SI or Sinuosity Index is channel length by the valley length. Channel length is the actual length of the thalwick, the actual length of the longitudinal profile, whereas valley length is the length of the meandering axis. This ratio is called as Sinuosity Index. Now, if this Sinuosity Index is 1, it implies the river is perfectly straight. If the Sinuosity Index starts becoming more than 1, then we know the river is starting to take some bends. I hope this concept is clear, all of you. Okay, you have to first understand what is channel length, and you have to understand what is valley length. Okay, valley length is the length of the actual channel, actual meandering axis, whereas the channel length is the length of the actual river. When the ratio is 1, it means the river is a straight river. When the ratio is more than 1, it means the river is now taking meandering bends. And then we have some relationships, okay, that tells us when a river will meander, okay, or when a river is sinuous and when a river is straight. So guys, tell me, do you have any questions to clarify on SI first? What is meandering belt axis? Okay, meandering belt axis. Okay, yes, similar to distance and displacement. Perfect, perfect. Okay, displacement becomes the shortest line, and distance is the actual length that we have. Always valley length is less than the channel length. Exactly. The valley length is either less than or equal to the channel length. Perfect, Manoj Kumar. Okay. What is valley length? Okay. You have to see the diagram, all of you. Okay. We'll talk about SI afterwards. But do you understand? Okay. Thalwick length and length of channel are the same. Yes, exactly. The thalwick length and the length of channel are the same things. Are the same things. Exactly. Yes. Channel length and thalwick. No, they're not different. They're same things. There's slight difference because thalwick is more about the deepest point, but doesn't matter. It's almost the same. Yes, the diagram shows a bit of difference. Okay, actually, the thalwick. Yeah, listen, all of you, listen. The thalweg is the profile along the deepest point of a river. Okay, whereas the channel length is the midpoint of the crossovers. Again, must take a paper for all of you. Okay. All of you, please listen to what I'm saying. If this is the river, okay, if this is the river valley, okay, you can all see this. This is the crossover. And if I join the crossover midpoints, I get the channel length. Whereas the deepest point may not be exactly at the center of the river. Okay, that's how thalweg length is not always equal to the channel length. Okay, because the thalweg is along the deepest point of the river, whereas the channel length is the midpoint of the crossovers. But let's not break our head into all of that. Okay, let's keep it as the channel length, as the length of the river. Okay, okay. So I will share, okay, it again. I will share it again. Here it is. Okay, here it is. SI is LC by LV. Okay, LC is the channel length, LV is the valley length. When the river is perfectly straight, LC and LV are same. When the river starts meandering, then the length of the channel becomes more, whereas the axis, the exactly straight line here, this will be shorter. That's how the relation is established. Okay, so this ratio is the Sinuosity Index. Now, once you understand this, uske baad bahut aasan hai. There are 3 values you must remember. SI less than 1.05. Would I repeat what is Sinuosity Index? Take out your textbook, please, all of you. Take out your textbook. Page number 406. Are you all with me? Page 406. Second column, Leopold and Wallman. Okay. They divide river channels basically into 3 types on the basis of Sinuosity Index. Okay. And SI is LC by LV. And they say there are 3 possibilities. When SI is less than 1.05, it is between 1.05 and 1.5, and it is more than 1.5. That's all. Okay. If it is less than 1.05.
The question, Apurva, I'm attending, right? Please confirm.
Yes. All good and nice.
Yes.
Hello. Okay. Can all hear me? Right. So if it is less than 1.05, then it is a straight river. If it is between 1.05 and 1.5, it is a sinuous river. The river is starting to bend. If it is more than 1.5, it is a meandering river. Okay, and in the meandering river, there are many variations. Now look at this page. Okay, rather no, look at this page. Yeah. So this table I've scanned from page 407. Okay. Yes, you're right. SI can never be less than 1. Okay, that's impossible. Okay. The least value of SI is always 1, but here we take it as 1.05. It's all as good as 1 because no river is perfectly straight. Exactly. Yes, right. Yes, you got it. So it says if the straight channel, it is less than 1.05. Sinuous between 1.05 to 1.5. Meandering is more than 1.5. Okay. So if you have this, you have the relationship. Now there are 2 more values here. Okay. In the meandering, we can have some variations also. So braided channel, it is more than 1.4. Anastomosing, I'll talk about that. It is very high. Okay, sinuosity, it is more than 2. Okay. By the way, I'll ask you some questions here. Yeah, please, all of you listen to me. SI is about the whole river, not just the cross section. It's from the origin right up to, it's along the river length. Okay. Now listen to me, all of you. You tell me which type of river will carry more of suspension, straight river or meandering river? Which type of river can carry more amount of suspended river? Suspended. Yes, exactly. Okay, suspended one is possible for straight river. No, meandering river, okay, is not capable of taking too much of suspended, because a meandering river is slow, exactly straight, and that's what is right. Okay, fine, thank you. Now look, come back to your screen. So if you have a straight channel will have more of suspended and some amount of bed load maybe. By the time you come towards meandering channel, you'll have more of, again, mixed load. Okay. And meandering channel will have more of point bars. Meandering channel will have more of depositions. Remember we talked about asymmetric shoals yesterday? Okay, the ideas, the 5 stages. In the first stage, the shoals on either side are asymmetric. That's what it says. In a straight channel and a sinuous channel, there are skew shoals. Skew shoals means those asymmetric, okay, position of those depositions. Whereas meandering one will have more of point bar formations and also riffles and pools. So this, okay, and straight channels, okay, will have less widening, whereas meandering ones will have meandering widening. Like, understandable, a meandering river is going to be very, very broad. How the width of the depth ratio is easy. If it's a straight river, the width will be less. So W by D ratio is less. If it's a meandering river, the width is more. So its W by D ratio will be more. In fact, this thing is discussed in another presentation. It is here. Yeah, it's here. So if you have got high sinusity, okay, you have got low sinusity, some relationships here, and we talk about the W by D. So with suspended channels, the width is lesser. If it is bed load channels, the width will be more. Okay, so you can skip this table for now, and we focus only on this table. The river that flow in hills. Now see, in the hills, the river is a bedrock channel. Harsh Gupta, listen to me. All of what we are discussing are rivers which are alluvial channels, not bedrock channels. I have explained this to you in the discussion earlier. In the hills, we have bedrock channels. The depositions are very less. So all these principles do not apply to bedrock channels of the hills. So when they come down on the floodplains, we talk about this type of relationships. Straight river is flowing fast. Yes, you're right. Because they flow faster, along with lot of mixing, that is why they will have more of suspended load. Anastomosing is different. We'll move on afterwards. Okay, so no river is zero suspended load. Okay, the degree will vary. Suspended load, okay, will be there in all rivers. I'm not saying, okay, it's not there. But anastomosing channel is a different case. Will not put into these 3 categories for now. Okay, so I think the basic, just listen to me, all of you. Do not get into too much of technical details. Okay, the exact values, avoid all of that. We want a simple answer. What is the concept of Sinuosity Index and how does that impact the type of channels? That's all. How does that impact the channel patterns? So don't get into too much of complicated discussions here. Okay, because if you look at all the values, then I'm sorry, I can't explain all of them. So keep it okay, as simple as possible. Broad river, less broad river, deep river, less deep river. You don't have to draw the whole table here. There are some other factors also missing here. Just keep it to basic discussions. Ganga will have, yes, in some parts, Ganga is a bedrock channel. In some parts, the Ganga is a alluvial channel. In some parts, Ganga is a braiding channel. In some parts, it is an anastomosing channel, so on. On the peninsula, it is a bedrock channel, hard rocks. So we don't apply this principle to peninsular rivers. Okay, fine. Now we move on, please. Okay, thank you. Yeah, now listen. So get this section ready to answer if you asked on what are channel patterns. Now, from this channel patterns, okay, based on the type of SI index we have a bit more detailed discussion. Page number 409. Can you please open up page 409? So we have straight channels, meandering channels. Okay, page 4011 has braided channels. 412 has anastomosing and ana-branching channels. All of these are types of alluvial channels, and all of these depend on the Sinuosity Index. So even without reading, say page number 409, okay, straight channels scarcely exist outside labs. Okay, it says in a straight channel possible maybe for short distances like 100 meters. It talks about some values of SI which is less than 1.05, so no big deal. Meandering channels, the next one, okay, it has SI of more than 1.5. They're common, okay, along alluvial rivers, characterized by pools and riffles. Okay, you know what are pools and riffles. And then the discussion we had earlier from E.A. Keller's ideas, the same thing apply here, that the development of meander goes through 5-stage process. 5-stage where the river is first straight, okay, then the river starts becoming slightly sinuous, and ultimately it starts becoming meander and then braiding and anastomosing. So this is nothing but more or less your Keller's ideas about how a river transits from a straight river to a sinuous and a meandering river. So page number 409 and 4010 talk about these stages. Come back to 409. We have last paragraph. E.A. Keller proposed a 5-stage model of development of meandering channel, pool riffle sequence on the basis of evidences of regularity of pools and riffles. Same idea, 5 to 7 times pool to pool and riffle to riffle and so on. Page 410 is the first stage, the second stage. So exactly that discussion we had, you have to come and apply it here. And this section also says that we do not know very well why meandering happens. Page 410, please be with me all of you. Page 410, second column, look at the last 4 lines. It says, although a great deal is known about the behavior of meandering streams and about their statistical properties, it is still not possible to define the ultimate cause of meandering. The ultimate cause of meandering, why it happens, is still not very well known. So read up these 2 paragraphs here. Now I want a small discussion on what are braiding channels. Okay, by the way, this page has a summary of the 5-stage model. Okay, the first stage, second stage, and so on. Okay, now I'm going to explain what is a braided channel. See what happens when a river has too much of sediments. The river course is no longer maintained. The river now starts overflowing its channel, and the water starts to spread out. Now when the water starts spreading out, there are other smaller channels that develop. Now, if the smaller channels are kind of fixed, they don't change with season and time, we call it as anastomosing river. But if the smaller channels are not fixed, the river can take up any random path, then we call it as a braided channel. So braided channel have multiple channels, bars and islands, highly erodible banks, unstable bar and islands. There are temporal changes. It keeps on changing. Frequent changes in banks and thalwigs. It has very high width and depth. So width is very, very high, depositions, and highly erodible bank, less total width, okay, and so on. You can skip this point here. Anastomosing, however, is a special type where the channels, okay, are stable and retain their identities without changing discharge with time. So both braiding channel and anastomosing channel have multiple channels. But the difference is in a braiding channel, okay, the course is not stable. It keeps on changing. Page number 411. Okay. 411, first column, braided channel. All the points I have summarized it here. A braided channel is characterized by multiple channels, where these channel ways are divided by bars and islands, shifting, highly erodible river banks. Okay, they're unstables and so on. Whereas the anastomosing channel on the next page. Okay, this is a special type of a braided pattern. Both are having multiplicity, but look at the last 4 lines. An anastomosing pattern is one where there are many channels, but they are stable and retain their identities with changing discharge and time. Now, one discussion you can add to this is, okay, you can write this down, please. Page 411, second column, last paragraph. Second column, last paragraph. There are several causes that have been assigned to the development of braided pattern. Incompetence of the river to transport load. The river is not capable of transporting load. Like high channel resistance to flow of the bed load. The bed load is not carried very smoothly, and that bed load can start resisting the channel. Highly erodible banks. Fluctuations in the discharge change. Sediment transport, bank erosion. Okay, we can have steep gradients where the river can bring a lot of sediments. Okay, in the upper reaches, we can have this along with abundant of bed load. So all of this, okay, and braiding is the braiding is not only because of excess bed load; it's also because of aggradation and depositions. So this paragraph kind of sums up under what conditions do we have braided patterns. So guys, this topic, I hope you understand. So if you have any queries, let's see. Okay. Now somebody asking, now listen to me. Now this is the value addition. Okay, please note this down. This is the value addition. Ana-branching basically is one of the channels which is much longer and goes and joins the main trunk. Okay, so ana-branching is nothing really difficult. It's one of the offshoots. Okay, offshoots, it is one type of anastomosing. It's just that one of the branch distributaries is very, very long. That's all. Why braided channels are unstable? Because there is more water than the width of the channels individually. That's why. Like Majuli. No, Majuli will be more like an anastomosing channel. The channel doesn't change. Okay. Majuli is more like an anastomosing. But Brahmaputra downstream kind of becomes a bit of a braiding channel. Braiding happens lower course. Yes, it happens. Yamuna and braiding, I do not know. Generally, braiding is a feature of the delta regions. Achha, now listen. No, please don't apply this concept of all this in Himalayan rivers. Why? Because Himalayan rivers in the upper course are bedrock channels. I've repeated this for you. All of this does not apply to bedrock channels. It only applies to alluvial channels. When you measure the river, you consider the whole river, but don't apply this index to the upper streams. So there we have structurally controlled rivers. Tista, an example of avulsion. I don't know. I mean, it's river shifting. Avulsion is different from stream derangement. Avulsion happens because of river depositions, whereas derangement can happen because of tectonic reasons. All of you listen, is asking me, is Tista an example of avulsion? I do not know, but I'm differentiating that stream diversions are of two types. One type of diversion is when the diversion happens because of the river depositions. The second type of diversion happens because of tectonic reasons. The one which happens because of depositions is called as avulsion. One that happens because of tectonic or other fact is called as river derangement. So I do not know if Tista was derangement or avulsion. Yes, it does. Kosi avulsion? Yes, you can say so. That is definitely depositions. Yes, I was saying something about value addition. Now listen, when you are discussing the difference between Himalayan rivers and the peninsular rivers, there you can bring this idea in. That the Himalayan rivers are bedrock channels. Himalayan rivers, okay, they flow through harder rocks. Whereas the the peninsular rivers, the peninsular rivers are bedrock channels. Whereas Himalayan rivers on the plains are alluvial channels. And then say something about avulsion, braiding, and the rest. Which is longer, channel length or valley length? Channel length. Valley length is along the meandering axis. Okay, Shivam? Avulsion and river linking, yes, you can, but I do not know how you want to use it. Lower courses, yes, lower courses exactly near the, you can say the coast. Yes, when we have deltas, they can have that. All of them near the deltas. Like in fact, Godavari is an example of an alluvial channel toward the deltaic region. Yes, that's the value addition, Deepak. You can use all of these concepts as a part of discussion under Himalayan rivers and peninsular river comparison. And when you talk about floods, you talk about river shifting, you talk about depositions, even by effluents and pollutants, you can add all of this. How do we link? You have the answer. Okay, anastomosing channels have an SI index of more than 2, whereas braided channel have SI index of more than 1.3. Your page number 407 has that. Jhelum is bedrock. Now, Jhelum along the Kashmir Valley is not bedrock, but Jhelum along the high reaches can be a bedrock. Yes, avulsion is alluvial area. Why? Why? Because it has deposits there. Okay, guys, I think we are more or less done. Pool formation causes sinuosity. Yes, it does. Pool and riffles together. Okay, pool and riffles together creates sinuosity and meandering. Okay. Yes, you have your assignments for tomorrow. Okay, all of you, please take down the questions, please. We have some questions for tomorrow. Okay. So one question is, what is Sinuosity Index? Yes, Abhijita, you can use the concept to differentiate Himalayan from the peninsular rivers. Yes, you can. पहले आप लोग please question लिखिए. Yeah. The question is, one question is, what is Sinuosity Index? Discuss how it determines channel patterns. What is Sinuosity Index? Discuss how it determines channel patterns. Okay. What is Sinuosity Index? Discuss how it determines channel patterns. Another question is, okay, discuss and differentiate braiding channels from anastomosing channels. Discuss and differentiate braiding channels from anastomosing channels. Okay. The first question is worth 20 marks. The second question is worth around 15 marks. Okay. And if you want, you could write a note on meandering channels along with what controls meandering and what are the stages of the meandering. That's your choice. Write a note on meandering channels. So guys, I have taken care of channel morphology. Okay, and if you have questions from this, I don't think you should get stuck here. Question number 2 and 3. I repeat the question. Please listen to me. Okay. The first question is, what is Sinuosity Index? What is Sinuosity Index? Discuss how it determines channel patterns. Discuss how it determines channel patterns. The second question is, okay, discuss and differentiate braiding channels from anastomosing channels. This question is worth 15 marks. The previous question is worth 20 marks. And you may also write a note on meandering channels. That could be 15 marks maybe. Yes, I'll upload the questions on the portal also. Okay. But give me some time, slowly, gradually, all of this will get organized. Right now, I'm kind of racing against time. Okay, so I have checked the portal. They have not? Okay, I'll find out. They should have by now. I'll find out. The value addition is when you use these concepts to compare peninsular rivers with Himalayan rivers. Harshit, too much of spoon feeding. I agree. Yes. Word limit, yes. If it's 15-mark question, write in about 150, 180 words. If it is 200 words question, you can try around 200 to 30 words also. Don't ask this question. Come on. Differentiate in tabular or paragraph. Okay. Nothing has to be entirely tabular. I showed some examples to you. Can suspended load impact sinuosity? Okay. Generally, yes, but it's more of the bed load reason. Why? Because we want sedimentation to have sinuosity. Okay. Now listen. For tomorrow, I will discuss some concepts from what's called as drainage morphometry, page number 353. For tomorrow, I'm discussing something from drainage morphometry. It is not in your syllabus, okay, but I never know. I mean, I'll take about 1 hour, I'll finish off some topics here. And if time permits, I think it should permit, I'll take up some topics of profile, okay, and the concept of graded river also. Okay, so that's the agenda for tomorrow. Tomorrow again, tomorrow our session will start at 6:30, not 6 o'clock. 6:30, and you will either use the same link or I think we'll give you a new link, okay, to join us tomorrow. By the way, I do not know why the attendance today is a bit less than what we had yesterday. Okay, we have close to almost 400 students now, but I can see good 110 approximately are absent. So I do not know what the reason can be. Okay, so if you have any issues, let us know. Link is not working. I have no answer for that. Yes, they should have uploaded. I'll check it again. It's raining. Where is it raining, Chirag? Which part of India is it raining? Delhi? I don't know. Noida is not raining. Pune it's raining. Jaipur it's raining. Udaipur it's raining. Haryana raining. Wow. Okay, so God bless us. So when we start studying, India wins matches. And when we start studying, it starts raining. Our desert is also raining. So I think all of us together are pretty good and lucky for India. You know? So good, nice. Okay, it is pleasant. Okay, because of Vayu, the storm. Okay, fine. But let's hope it's not as bad as it was in Odisha. Okay, we just pray. Okay, Vayu turns and goes anywhere. It has a very nice country near India where it can go to, but not Gujarat. Okay, I mean, this joke there, bad joke. All people are important. You can go to, even to Oman. Okay, where is Junior Shabir? Okay, he is thankfully outside, not bothering us. Okay, guys, we had nice time. I hope you all are learning along with me. Okay, please provide login for Zoom to avoid every day. This everyday thing will sort out only when I make a complete chart. Okay, Volcut maybe rain. Yes, rain. Okay, so nice guys. Take care. Goodbye. Okay. By the way, listen, all of you. I think I will create a new channel only for geography because it's becoming a bit messy posting the geography announcements on the GS page. Okay, the GS I'm keeping for the ethics is the ethics week. So I think, is that okay, all of you, if I have a separate channel for geography? Okay. Separate channel, okay. And are you all looking into the essays channel also? Okay, the yes. Are you all looking essays channel also? Please do, because we are working very, very hard. Okay, not yet. Essay is going. We have just started. I have not really picked up the pace on essays because my focus was more on the optional part. But the GS is picking up pace. Okay, we have started with ethics. Okay, and good, nice work. Okay, so please, all of you, keep studying. Okay, enjoy, be happy, be sincere and not serious. Okay, and enjoy. Okay, so take a short break, summarize. We'll catch up tomorrow. Okay, bye bye. Good night. Sleep well. Okay, and enjoy.